Hello, my name is Eduardo. I'm a partner solutions architect with AWS, and I have the pleasure of having me here today, Christy. Hello, Christy.
Hi, my name is Christia. I'm a technical seller from IBM supporting the AWS partnership.
So, Christy, I wanted to talk to you about the topic of the moment, right? Generative AI, right? There's a lot of customers out there that are looking to build new applications with generative AI solutions, and they're trying to build new virtual assistants. They're trying to build content generation solutions, or predictive analytics, and generate new data insights, right? And for this reason, these customers, they are looking at ways that they can use their accumulated corporate data, right, so that they can uh, enhance the responses that are generated by base large language models with their own data, right, that is meaningful to their use cases and to their customers and their internal users, right? Now, these customers, they have been accumulated a lot of data over the past years, right? So that can be relational databases like Amazon RDS. It can be data warehouses like Amazon Redshift or DB2 data warehouse, or even Tisa, right? Or there could be unstructured data sitting on Amazon S3 buckets, data lakes, or NoSQL data like in Amazon DynamoDB, right? Now, how is it that these customers can combine all of this data and bring all of this data together to build generative AI applications?
So, with IBM watsonx.ai, it is a hybrid open lakehouse with multiple fit for purpose engines supporting analytics and AI workloads, and it's available as SaaS on AWS. Its open architecture includes built-in governance and supports different data sources and formats, ensuring secure data sharing across your organization and facilitating insights from your enterprise data through a unified platform. The solution simplifies your data landscape, giving you access to all of your data wherever it resides, including transactional data from Amazon RDS for DB2, analytics data from DB2 Data Warehouse and Netezza Performance Server, and data lakes stored in Amazon S3, AWS Glue, Amazon EMR, and others, as well as from IBM Mainframe by using IBM Datagate for watsonx.
Wow, that's very awesome.
And it supports open table formats like Apache Iceberg and optimizes analytics for large datasets. It handles various data formats like Parquet, Avro, JSON, and CSV. And customers can select from a different open query engines such as Presto and Spark for their workload requirements. And IBM recently released Presto Engine C++ as well to offer improvements in query performance. And a few examples of what fit for purpose engines can be used for. So for Spark, for example, can be used to do data ingestion and data preparation and also machine learning or even vector embedding. While Presto and Presto C++ allows you to run interactive queries to find the data or insights you need over large amounts of data.
Very, very interesting.
And watsonx.data also enables you to have a single copy of data usable across your organization, reducing the need for ETL processes, data movement, and duplication. And it has a built-in data governance capabilities and compatibility with IBM Knowledge Catalog, ensuring secure data access and sharing across your organization, making your data available to AI models or applications of your choice with data governance, lineage, and reproducibility.
Yeah, and this is very critical for our customers, right? Because they have a lot of concern about who's accessing their data, how is that data being used, what's the quality of the data, and obviously I don't want to duplicate my data, right? So I want to have a single copy of my data.
That's right.
Now, this is a very good explanation that you just provided us. Can you give us some examples of what are some of the common use cases for a lakehouse architecture?
Sure. So some of the common use cases, some examples include ad hoc analytics, data transformation, data sharing, BI workloads, or even machine learning and generative AI workloads. Also, there's data warehouse optimization, data lake modernization, using mainframe data for AI and data store for Gen AI.
That's very, very interesting. Now, I do see here you've mentioned vector embeddings a while ago, and I see here that we have Milvus as part of watsonx.data. Now, Milvus is a vector database, right?
Yes.
Now, can you explain to us what are some of its capabilities and what are some of the features that customers can take advantage of with Milvus on watsonx.data?
Yes, so that's correct. You can now provision Milvus in watsonx.data. It uses an open source embedded vector DB to store and query vector data. This service is used for tasks like similarity search and recommendation systems in generative AI use cases. It gives data scientists and engineers the ability to curate and prepare data for tasks such as retrieval augment generation, or RAG, use cases. With vectorized embedding capabilities, customers can refine and optimize their AI models to produce accurate responses and insights from the trusted data. So, for example, in an image or audio search, data with similar characteristics to a vector can be quickly retrieved.
That's very interesting. Now, what are some of the use cases that customers can build using a vector database?
Sure, so some examples are an image or video similarity search. It can be personalized service and proposal or recommendation systems. And it can also be question and answer systems with natural language processing.
That's very cool. Now, obviously, when we talk about Gen AI and RAG applications, I need to have some kind of Gen AI platform, right, to use Gen AI models, right?
Yep.
Use large language models. And so I see here in this diagram that we now have a new entity here. And we see that I have IBM watsonx.ai in the picture, right? And it's running on my AWS account, on a customer AWS account, on top of Red Hat OpenShift service on AWS, right, or ROSA. So let's take a look at how IBM watsonx is being used in this scenario to generate the embeddings and also to interact with Milvus. Can you walk us through some of these characteristics?
Yeah, so as you pointed out, Eduardo, watsonx.ai is IBM's advanced enterprise AI platform designed to streamline the development and training and deployment of AI models. It can utilize the data retrieved from Milvus to perform deeper analytics and generate insights that add value to your applications. RAG allows you to augment the capabilities of your large language models, like IBM's Granite, with your own data across many use cases like recommended search, creating question and answers based on chatbots, and more. And what's also very interesting to point out is that 90% of customers' use cases are actually involve RAG patterns.
Oh, that's very interesting indeed. Now, let's take a look at how this flow is happening for this particular scenario. Like if I'm implementing a RAG use case and I want to use my corporate data, I need to push that data somehow into my vector database so that I can do my searches, right?
Mm-hmm.
So imagine that I have here data that's being received on my Amazon S3 bucket, right? So this could be triggering notifications that can land on something like Amazon SQS. And since I'm having ROSA here, right, I can easily deploy also containerized applications in there that are going to be pulling the messages from this SQS queue, and then they're going to retrieve the files or the information that I have stored on my S3 buckets, and they're going to parse those files, they're going to load that information, and then they're going to invoke my embeddings models, right, to convert that information into vector embeddings, right? And these vector representations of my data, they need to be then stored in my Milvus so that I can do the similarity searches and so that I can also do the semantic capture when I'm doing my RAG use cases, right?
Correct. So we then connect to Milvus and insert the generated embeddings from watsonx.ai into the Milvus collection. Once the embeddings are stored in Milvus, you can use Milvus to perform similarity searches. So when a query comes in, it's converted into an embedding using the same model and then compared with stored embeddings to retrieve the most similar data points. And this retrieved data can be used to augment the generative AI responses, providing contextually relevant information for those RAG use cases.
Now let's take a look how the users actually come into play, right, in this architecture.
So users will submit a question or statement as a prompt, and relevant keywords are extracted from the prompt and delivered to the embedding model. The embedding model then converts the prompt into a vector for semantic search against the documents stored in Milvus, and the most relevant results are returned back to the LLM.
All right, so if I understand that, so I get the data back from Milvus into my LLM, and then with this additional data that's coming from my vector database, I can use that data to augment the original user prompt, and that was submitted to my large language model, right? And the large language model now responds with much richer and contextually relevant information, and this allows the LLM to generate the answer that the users are looking for by considering the most similar search results and the initial prompts made by the user, right? So the generated answer then is sent back to the users, and it provides them with all the details that they need to fulfill whatever use case that might be. But most importantly, it's not only using the base data sets that were used to train my large language model. I'm expanding the capabilities now with this RAG pattern, so that I can use the corporate data that we've talked about to generate the responses that I'm looking for, correct?
Exactly, yeah.
Yeah, this is a great example of how customers can build generative AI applications on AWS with IBM technology. And I think this is a very valuable example for our customers, and I really appreciate you taking the time to walk us through this today. This is great information. Now, Christy, watsonx.data is already available on AWS, as you've mentioned previously.
Exactly. So watsonx.data is available on the AWS Marketplace as a fully managed SaaS listing.
And I believe watsonx.ai and .data also have options to deploy for self-hosted deployment on ROSA if customers so choose to do that, right?
Correct, yes.
All right, thank you. Thank you very much.
Thank you so much.
Thank you. See you next time.